Hello everyone, I'm Adam. In this problem, we want to illustrate that our two functions f of x equaled e to the 2x and g of x equals natural log of the square root of x are inverses of one another by sketching the graphs in the coordinate plane over here. So what we're going to do to sketch the graphs is basically pick some values of x, find some values of y, and plot some points. So to start with, say for our first function, say f of x is e to the 2x, and we'll go ahead and get it set up for our next function as well. So values of x, and for our function g of x is the natural log of the square root of x. So let's take a look at this. So we'll pick values of x. Let's say take x equal to -1. So plugging that into our f of x would give us, say, e to the -2 as a y value. Right. And see what that is. E to the -2, or 1 over e squared, get something approximately equal to 0.14, and we'll take just a couple more. So x is -1, let's say take x is 0, and we'll do x is +1 as well. So when x is 0, we get e to the 2 times 0, or essentially e to the 0, which is 1, and when x is 1, we get, say, e squared, which e squared give us something approximately like 7.4. So let's go ahead and plot these points and kind of sketch the graph of our e to the 2x function. So when x is -1, we're at about 0.14. Right. We have our point -1, say e to the -2. When x is 0, y is 1. And when x is 1, we're at e squared, or approximately 7.4 up here. All right, so looking at this graph, okay, connecting our points. So that's the graph of our f of x equals e to the 2x. Now we're going to sketch the graph of g of x equals natural log of the square root of x. And to illustrate that these two things are inverses of each other, these two functions, what we're going to hope to see is that the graph of our g of x is going to be essentially the same graph as f of x, but rotated around the line y equal to x. So we'll take a look at that. Let this be our line y equal to x. And so if the graph is the same, what we're going to hope to see is that there's going to be a switching in the coordinates of our points. So for example, here when x was -1 and y was e to the -2, if this is our inverse, if we take e to the -2 and plug it in, it should give us back a y value here of -1. So let's see that. So plugging in e to the -2, so ln of the square root of e to the -2 is equal to ln of just e to the -1, which the -1 can come out in front. So you have -1 times ln of e, which is essentially just -1, which is what we get. So let's go ahead and do the same thing. So what I'm going to do is take the y values, right, from each of these points and plug them in as our x values, and see that we should get the y value here corresponding to the x value for f of x. So our y value, when x was 0, we got 1, so we'll plug in 1 here. So ln of the square root of 1 is just ln of 1, right, which is 0. And then lastly, e squared, so ln of the square root of e squared just going to be ln of e, which is 1. So in fact, we do see this kind of switching of the coordinates. So that in itself kind of confirms that these are inverses. But let's go ahead and sketch the graph. So e to the negative 2, we have a y value of negative 1. So e to the negative 2 is about 0.14. So e to the negative 2, y value of negative 1. When x is 1, we have a y value of 0. And lastly, when x is e squared, or approximately 7.4, we have a y value of 1. So at about 7.4, we have a y value out here at 1. All right. So in fact, it does look like the graph of g of x as the natural log of the square root of x is the graph of f of x equal to e to the 2x rotated around our line y equals x, which confirms their inverses. Thank you very much.